This is going to be a flip video about moles and AMU. So first of all, let's just remember, AMU stands for Atomic Mass Unit. And for our sake, we could say our atomic mass unit is basically the same thing as mass. And so if you remember on the periodic table, we have different elements. And so if we look at sodium, the number underneath here with a decimal is the mass of this element, is the mass given. We call this the atomic mass unit. Atomic meaning it's from the atoms on the periodic table, and that's our atomic mass unit. We can also just say that this is the mass, okay? In this video, we're going to figure out how to connect moles and mass together. Moles and mass together. So we already know a relationship about moles. So let's just review our old relationship, and that is 1 mole is equal to 6.02 times 10 to the 23rd of any particle. And remember, in chemistry, our particles are atoms, molecules, and formula units. Okay, well, we have a new relationship, and that is also 1 mole is equal to the mass from the periodic table of any atom you want to talk about. So, for example, again, from my periodic table, if I bring back sodium, this mass from the periodic table of sodium is equal to 1 mole. So let's take a look at another atom. How about carbon? This mass seen here on the periodic table, 12.01, is equal to 1 mole. I can do that for any element on the periodic table. So that's important to write down. 1 mole is equal to any of the masses seen on the periodic table. We can also, whenever we use mass, use the unit G for grams. So let's remember that. G for grams is the unit for mass. Okay, what would some practice problems be? Well, now that we have our new conversion factor, it's important to write this nice and big, maybe add it to the page that you have all of these conversions on. Okay, it's another conversion factor. Let's take a look at some problems. How about we start with this one? How many grams are there in 2.0 moles of sodium? Okay, so we have to remember something. We have to remember that we have to use dimensional analysis, and in dimensional analysis we start with our given, same way we did in the old problems. And in this problem, I want to know how many grams are there. Grams is mass, so I want to go from moles to grams, which is mass. So is there a conversion that can get me from moles to mass? Well, let's bring back our conversions that we know. So far, our old one, this goes from moles to particles, so that doesn't have mass in it. And our new one, moles and mass in grams. This is the conversion factor I'm going to need, our new one, because I'm starting with moles and I'm going to mass, which is recorded in grams. Okay, good. So I have my conversion factor. Now I'm going to begin. I always start with my given over here, 2.0 moles of, remember, what do I have? Sodium, moles of sodium. Multiply it by my conversion factor. Copy this unit here down below, moles of Na, and ask myself, what is the relationship between moles and grams? And here it is. 1 mole is equal to the mass from the periodic table. So at this point, I have to pull out my periodic table to fill in the top part. So I want to use grams of Na. You want to make sure you use the unit, grams of Na. So let's pull out our periodic table and find Na. Here's my periodic table. I'm going to cheat a little bit here and show you Na. Na would be over here in the metals, and I find it, so it's a good to use your sticker, and I want to make sure that I record the mass, and let's just go up to 2 decimal places, like your sticker does. 2 decimal places. So 22.99 is the mass. I'm going to plug that in here, 22.99. Grams is my unit of Na. This and this should cancel out. Now take out your calculator, multiply 2 times 22.99 divided by 1. or 2 times 22.99. Get a final answer, and then remember, always look at your given for sig figs. 2 sig figs here, and your answer has to have 2 sig figs. Make sure you record an answer, so go ahead and do that now. And remember, your unit is going to be grams of Na. Okay, let's do another problem. Let's take a look at this. Slightly different, but similar concept. How many moles are there in 6.0 grams of C? C stands for carbon. Okay, let's decode this. Here's my given, 6 grams of carbon. I always want to start with my given. I'm trying to figure out how many moles. So I want to go from grams to moles. Grams to moles. Do I have a conversion factor that can get me from grams to moles? Well, let's see. Again, so far the only conversions I have are my old conversion. 1 mole is equal to 6.02 times 10 to the 23rd of any particle. And if you notice, this has moles and particles. Do I want moles and particles? Let's see. I want grams, so mass, and moles. Nope, nowhere in here is there grams. Grams is not a particle. So I can't use this one. It doesn't give me a relationship. How about my new one? Again, there's only 2 conversion factors here. How about my new one? 1 mole is equal to the mass from the periodic table. Moles, mass in grams. This works. Mass in grams and moles. So what's this conversion factor? Not my old one. All right, then let's begin. I put my 6.0 grams of carbon here. I always start with my given, and I want to multiply it by a conversion factor. I copy whatever unit's here down here, only the unit, and now I got to use my head, right? I'm going from grams to moles of carbon, grams to moles. This needs to cancel out. That's why I know I put it in the right direction. And now I ask myself, what is this relationship? 1 mole. 1 mole. Get the mass from PT, periodic table. All right, let me get my periodic table back, and let me find carbon. We're now talking about carbon. Carbon is a nonmetal above the staircase. It would be right around here. Here's carbon blown up for you. Here's the mass, 12.01 grams. So I plug in 12.01 grams. And now all I have to do is get my calculator out and solve for this problem. So it would be 6 times 1 divided by 12.01, or 6 divided by 12.01. So go ahead and take out your calculator at this time and calculate that. Don't forget to tack on the unit moles of carbon. Good. When you're done, your answer should have 2 sig figs. Remember, a trailing 0 with a decimal is significant. So 2 sig figs. So my final answer should have 2 sig figs. You might want to go back to my flip video and watch the rules of sig figs in order to refresh your memory. Okay, now, how in the world does this relationship actually exist? How in the world did I know that any of these masses are equal to 1 mole? Like, how did that happen? Here's a little history for you. Avogadro is the guy we associate with moles, and he's the scientist that he went into his lab and he got 12 grams of carbon. Okay, he put it on the scale, made sure it was 12 grams. And at this time, he didn't really know much about moles. He didn't really know much about mass. He didn't really know much about the periodic table. Maybe a little things here and there. Okay. From that 12-gram sample of carbon, he said, I'm curious, how many atoms are in that 12 grams? Okay. Now, it would be nice to say that he actually hand-picked each one out, but that's hard to do because atoms are really small. So he figured out a way, right, probably mathematically, figured out how many atoms there were. And you know what his answer was? In 12 grams of carbon, there was 6.02 times 10 to the 23rd atoms. That's where he got that number from. Avogadro got that number because in his lab one day, he counted or figured out how many atoms there were in 12 grams of carbon. So, in other words, you can actually say 12 grams of carbon is equal to 6.02 times 10 to the 23rd atoms. And so what they did was then from there is they said, well, why don't we make that the mass of carbon on the periodic table? Right, here's carbon. Why don't we make that the mass of carbon? Right, a little bit more precise. And he said then, why don't we make everything else relative to that mass? So this, remember, 6.02 times 10 to the 23rd is equal to 1 mole. Right? 6.02 times 10 to the 23rd is equal to 1 mole. So we say in our new conversion, 1 mole is equal to the mass on the periodic table. That's equal to 1 mole. And so is every other element on the periodic table. So when you see something like sodium, they took 6.02 times 10 to the 23rd atoms and saw how much they were going to weigh. And when they figured that out, they recorded that to be the mass of sodium. So all of those masses are the mass of 1 mole of that substance, right? And sodium's ended up being 22.99. So 6.02 times 10 to the 23rd atoms of sodium weighs 22.99 grams. 6.02 times 10 to the 23rd atoms of any element, here, let's bring lithium, equals its mass on the periodic table. Good? So if you look up lithium's mass on the periodic table, it's 6.94 grams. I could do that for any atom. Any atom. So that mass you see is a sample. Now, instead of saying 6.02 times 10 to the 23rd atoms is equal to that, I can also just call that 1 mole. 1 mole is equal to that mass. I could also call this 1 mole. Why? Because 1 mole is equal to 6.02 times 10 to the 23rd. And that's your relationship between moles, mass, and atoms.